So one application of these proportions would involve aspect ratios or ratios within figures. So what I have here is I have two triangles. They're what we call similar triangles. What that means is one is just an enlargement or a reduction of the other. So let's give you this information. And I'm going to, technically I should tell you that this angle and this angle are the same, and these two angles are the same. Which means by default the third angle has to be the same. To compare similar figures, I first need to find the side from each figure that corresponds with the other. So the 24 here corresponds to which side from the other figure? The Y. Good. The 20 corresponds with the 10. And X corresponds with 7. It's the only one left. The next thing I need to do is I need to find the pair that I know both numbers in. The 20 and the 10, or 10 and 20, however I want to list it. I'm going to list it as 20 inches to 10 inches. That's a ratio. Now if I want to find X first, I first need to figure out, does X have to go on top or bottom in this ratio? Well, it has to go on top, and why would it have to go on top? Because it is from the same triangle as the 20 is. What then would go below the X? The 7 inches, because that is the corresponding side from the other triangle. What would I multiply here? 20 inches times 7 inches is 140 inches squared. And then? Divide by 10 inches. 140 divided by 10 is 14. Inches squared divided by inches is just inches. To find Y, I'm still going to use the 20 inches over 10 inches. Where does Y go, top or bottom? It's going to go on bottom. Why does it go on bottom instead of the top?
In the same triangle as the 10.
Perfect. It's from the same triangle as the 10 was. What goes above it?
24.
The 24 inches. Good. So now we cross multiply. 10 times 24, 10 inches times 24 inches is 240 inches squared. Divided by 20 inches is, well, 240 divided by 20 is 12. Yeah. Inches squared divided by inches is inches. So Y is 12 inches. That's an application when we hit geometry we'll come back and look at more. We're going to talk about two things that are very, very different, but are often confused for each other. Remember, a factor is a building block or a piece of a larger number. A factor divides into that number evenly. Factors are the numbers that can be multiplied together to make that larger number. Factors of 60. Well, 60 is 2 times 2 times 3 times 5. Those are the factors of 60. Multiples. You can think counting up by. Multiples of 4 would be 4, 8, 12. You're counting up by 4s, whatever. Let's do the multiples of 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5, 20. And it keeps going. Notice it's 1, 2, 3, 4, 5. You're taking each number times that. Each of our whole numbers or counting numbers times the number. Notice multiples are larger or equal to than the original number. Factors are smaller than the original number. We've talked a bit about greatest common factor. We used it for reducing fractions, abbreviated GCF. Greatest common factor is the largest number that divides into both numbers. So if I ask you to find the greatest common factor of 36 and 30. Some of you might look at that and be able to say 6 is the largest number that goes into both of them. If we were trying to do this using our factoring, 36 is 2 times 2 times 3 times 3. 30 is 2 times 3 times 5. Again, that would be found doing that factor tree. Like that. Look familiar? I'm going to assume you guys can do those at this point. But once we've got them factored, the greatest common factor, the key word there is common. What factors do they have in common? 2 and a 3. 2 times 3 is 6. 6 is the GCF. Greatest common factor. Least common multiple. LCM. Least means the smallest number that both of the numbers given divide into. So it's just kind of the reverse. The least common multiple of 12 and 18. Well, if I factor 12, it is 2 times 2 times 3. If I factor 18, 2 times 3 times 3. Least common multiples must have all of the same factors. If one or more of the numbers is missing a factor, we have to multiply it in. So let's look at what they have for common factors. They both have a 2. They both have a 3. But notice there are some factors that are not circled. Those are the ones that are going to tell us what to do. What does this top number still need that the bottom number has?
1.
Has an extra 3, right? Oh. So if I put a 3 on top, now they both have a 3, right? What's the bottom need to match the top? Another 2. Very good. So 2 times 2 times 3 is a 12. Times another 3 is 36. 2 times 3 times 3 is 18. Times another 2 is 36. 36 is the least common multiple of 12 and 18. It is the smallest number that both 12 and 18 will divide into without a remainder. So find the LCM of 30 and 40. I'm going to have you guys do the factor trees quickly for me to give me the factors of 30 and of 40. So what are the factors of 30?
3, 2, and 5.
2 times 3 times 5, yes. Well, how about 40?
2 times 4 times 5.
4 can be split into 2 times 2, right?
Oh, that's right.
So 2 times 2 times 2 times 5. So what do they have in common is a 2 and a 5. What's this top number still need?
2 2s.
2 and 2, 2 2s. What's the bottom number still need? Excuse me, 3. So 2 times 3 times 5 is 30. times 2 is 60, times 2 is 120. 2 times 2 times 2 times 5 is 40, times 3 is 120. So 120 is the least common multiple. Did any of you get that far, or did you guys just get the factors done? Got her? Okay. So I'm going to have you guys find this one. Find the LCM of, oh, what's a good one? Of 42 and 66. I'll give you a couple minutes there. Anybody get an answer yet?
462.
Okay, let's take a peek. If I factor 42, what do I get?
2 times 3 times 7.
2 times 3 times 7. Good. 66?
2 times 3 times 11.
2 times 3 times 11. And you're getting the right factors, but it's always easier if you put them in order from smallest to largest. So in common, we have 2s and 3s. What's the top one need?
11.
And the bottom one needs?
7.
The 7. Good. So it's 42 times 11. It's 462. 66 times 7 is 462. So yes, 462 is the LCM, least common multiple. Okay, let's look at operations with fractions. So, when we're looking at fractions, we had mentioned way back on the first day that something like 3/4 plus 1/5 couldn't be added. Why can't they be added?
They don't have the same denominator.
Good. To add, numbers need the same name. And for fractions, that is common denominator. So the first thing we need to do is to determine the common denominator. And a common denominator is nothing more than a common multiple. Now, throughout all of elementary school, you were taught that you had to find something called the least common denominator. Which was abbreviated LCD. Well, least common denominator is just the least common multiple of the two denominators. But you do not have to find the least or the smallest one. Any common denominator will work. And I'll show you in a little bit, I'll show you an example where we can do different ones. So we're going to deal with a 3/4 plus 1/5. The first thing we have to do is find common denominator for 4 and 5. There are 3 methods. Method number 1 is to use that least common multiple method I just showed you. Factor them and see what they're missing. Well, 4 is 2 times 2, right? 5 is prime, so its only factor is 5. So the top number needs a 5 and the bottom number needs 2 2s. So 20 would be the least common multiple or least common denominator. Second method would be to just list multiples. I would start with the 5 because we know 5 is just going to be 5, 10, 15, 20, 25, and so on, right? I probably wouldn't even list those because I would know one if I saw it. The 4 is going to be 4, 12, 16. Oops, I missed one. Oh, I skipped it. How about 4, 8, 12, 16, and 20? And we see there's 20 is the first number that matches between the two lists. So 20 would be the least common denominator. The third strategy would just be multiply the two denominators. And I'm putting a warning here that that might not be the LCD, the least common denominator. In this case, it would be. 4 times 5 is 20, which is the same as we got with the other two methods. So now that we know our common denominator is going to be 20, we must change our denominators to be 20. Now for me, my mind adds numbers vertically like this. So I'm going to set it up vertically. 3/4 plus 1/5. And I have to change both of those into 20ths. So now step back to last Thursday. What do I have to do to a 4 to change it into a 20?
Multiply by 5.
Times 5. So what do I have to do to the 3?
Multiply by 5.
3 times 5 is 15. Good. What do I have to do to the 5 to turn it into a 20?
Multiply by 4.
Times 4. So what do I do to the 1?
Multiply by 4. Gives you 4.
Times 4, so that's 4 20ths. Now that I have the common denominator, the same name, remember when we add numbers, we combine the counts. 15 and 4 make 19, and we keep the same name. So yes, it is 20ths. So 19 20ths. I might have 1/6 plus 3/8. First thing I need to do is find my common denominator. For 6 and 8, does anybody see what the least common denominator would be? You're thinking factor.
24.
24. What did we do to the 6 to turn it into a 24?
Multiply by 4.
Times 4. So the 1 is
4.
times 4 to be 4. What did we do to the 8 to turn it into a 24?
Multiply by 3.
Times 3. So 3 times
3 is 9.
3 is 9. So we combine the counts. 4 plus 9 is
13.
13, and we keep the same name of 24. 13 24ths. What if we had tried option 3 there, just multiplying the denominators? What is 6 times 8? 48. So it would have been 6 times 8 to be 48, so 1 times 8 would be 8 48ths. I'm going to rewrite my 1/6 and 3/8 here. This would have been 6 times 8, so 1 times 8 makes 8. This would have been 8 times 6, so 3 times 6 makes 18. 8 plus 18 is 26 48. Is that a different answer?
No, it's the same number as the double.
Extra step.
Exactly. I just have an extra step of reducing it back to the 13 24ths. So like I said, you were always told you had to find that least common denominator. It's not true. Any common denominator will work. The least common denominator will be the least amount of work. But any common denominator will work when you add fractions. So if you're looking at this and you are stumped, just do 6 times 8 is 48 and use that as your common denominator. That will always work. You may have to do some reducing when you're done, but it will always work. Let's have you guys try one. Let's have you do 2/3 plus let's see, what do I want to put in here? Let's do 1/7. See what you come up with there. I'll give you a couple minutes to do that one. So what's our common denominator here?
21.
21. Good. What's this going to be here?
14.
14. Good. 3 times 7, so 2 times 7 makes 14. What will this be?
3.
3. Good. 7 times 3, so 1 times 3 is 3. And we add to get
17 over
22 over 21.
perfect. Subtracting is just as simple. If I have 3/4 minus 2/5, the process is the same. I must first find my common denominator. For fourths and fifths, it's going to be
20.
20. Very good. So it's going to go here.
15.
15, good. 4 times 5 is 20. 3 times 5 is 15. What's going to go here?
8.
8, very good. 5 times 4 is 20. 2 times 4 is 8. The only difference is we are subtracting instead of adding. So we still combine the counts. What is 15 minus 8? 7. And we keep the same name, 20ths. So it's 7 20ths. You look confused.
So you times it over for the common denominator and then you subtract.
Yeah. So let's take something like 5/6 minus 3/8. I'm going to have you guys try that one on your own. For a common denominator, 6 times 8 would be 48, and that would work. Is there a smaller one we can use?
24.
24. 48 will work just fine. You'll get to the same result. You just have to reduce it to get there, yes. So what's going to go here above the 24?
6 times 4 is 24, so 4 times 5 is 20.
Perfect. 6 times 4, so 5 times 4 makes 20. How about here?
8 times 3 is 24, so 3 times 3 is 9.
Perfect. 8 times 3, so 3 times 3 makes 9. And we are subtracting, so 20 minus 9 is
11.
11, and we keep the same name, 24. If you'd had 48s, you would have got 22 48s, which would divide by 2 to make 11 24s. Well, let's look at multiplying. Now, if you go back, again, when we talked about multiplying and adding and stuff on the first day, when you multiply, you do not need the same name. You are going to, one, combine the counts, and then you are going to also combine the names. So to multiply 3/4 times 1/5, do I need a common denominator?
No.
No, I do not need the same name. I'm going to combine the counts. 3 times multiplying, so I use multiplication to combine them. 3 times 1 is
3,
3. 4 times 5 is
20.
20. Very good. So I might have 2/7 times 1/4. I would do, combine the counts. 2 times 1 is
2,
2. 7 times 4 is
28.
28. Am I done?
No, if you can reduce it one more time.
Yeah, both 2 and 28 can divide by 2 to give me
116,
1/14.
114.
Some of you might be looking at this thinking, why didn't he cross cancel? Others right now might be looking at it thinking, what's cross canceling? Well, what it is we know that on top we're just going to do the 2 times 1. That's going to become our new numerator. On bottom it's going to be 7 times 4. Well, we see that both the 2 and the 4 can be divided by 2. So we could actually do that before we multiply. We actually reduce before we multiply. Some of you heard cross-canceling called cross-multiplying. I hesitate to use that term because there's a couple of other processes that are called cross-multiplying, and I don't want you to confuse them. So I look at this, and since the 2 and the 4 are diagonal from each other, and both can be divided by 2, I'm going to divide them by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. 1 times 1 is 1. 7 times 2 is 14. So I get the answer already reduced. Basically, I'm reducing before I multiply. Now, in a problem like this, it's about the same amount of work either way. To either cross-cancel first or to multiply them out and reduce it later. But you can run into problems like this. (24 25ths) times 35 36. Well, if I look at that, 24 times 35 would be 840. 25 times 36 would be 900, and then I'd have to reduce, right? Now I'm sure all of you look at that and see how both of those can be divided by 60. Right? Totally, sure. However, I could save myself a lot of work here. 24 and 36. Good. What can both of those be divided by? Okay, 6 would be 1. 24 divided by 6 is 4. 36 divided by 6? 6. Now, if I look at those closely, those can still be divided by 2. Very good. 24 divided by 2 is 2. 6 divided by 2 is 3. I could have divided both of them by 12 at first if I'd have seen it. But just like reducing, I can keep dividing them if I want to. Is there anything else I can reduce here?
25 and 35.
You got it. 25 and 35 both divide by 5. What is 35 divided by 5? 7. 25 divided by 5?
5,
5. Good. So 2 times 7 is
14,
5 times 3 is 15. This is what you would have got up here if you would have reduced by 60. Most likely you'd have reduced by 10, then 2, then 3. But you'd have got there. But you can see this is a little bit less work. Multiplication is just that simple. Multiplying straight across, cross-canceling when it's necessary. Now, we said before that division follows the same rules as multiplication. I just showed you that I can divide straight across, or that I can multiply straight across. So does that mean I can divide straight across? Can I do 12 divided by 4 is 3? And 25 divided by 5 is 5? Get 3/5? Does that work? Is that the right answer? Sure it is. Does that work every time? Yes, it does.
really?
So why don't we do it that way?
Would be too easy.
Would it be too easy? Well, I'm sensing a little cynicism in the room here. It doesn't. We don't do it that way because we run into things like this. 3/4 divided by 2/3. If I tried to divide straight across, well, 3 divided by 2 is 1.5 or 1.5. 4 divided by 3 is 1 1/3 or 1.33333333333. It doesn't divide out evenly. What have we been taught to do with this?
Find the average
What
denominator.
is 5/4?
We multiply by
5/4.
well, I'm talking about this one down here. But yeah, up here you'd make that 5/4. Exactly right, and multiply. The 3/4 divided by 2/3, we would multiply by 3 seconds, yes. The first number does not change. Just like when we were talking about subtracting, changing it into adding the opposite, the operation works on the number that comes after it. So the division goes with the 2/3. It's the number that comes after it. So the 3/4 does not change. But instead of dividing by 2/3, we multiply by 3/2. So now 3 times 3 is 9. 4 times 2 is, and of course that's improper, so we can make it 1 1/8, right? Where does that come from? Why can we multiply by the reciprocal? Well, you may have had teachers in the past go through and show you, well, see if I multiply by 2, or if I divide by 2 or multiply by 1/2, it's the same. Multiply by 1/4, divide by 4, I get the same thing. There's actually a much simpler answer than that. A little bit longer answer, but simpler. This process of multiplying by reciprocal is a shortcut. Similar to, like I showed you the first couple of days, carrying when we add whole numbers or borrowing when we subtract whole numbers. Those are all shortcuts. Once upon a time, the way we would have divided fractions would have looked like this. I take the number I'm dividing by, the 2/3. Is that reduced? Is that in its simplest form?
Yeah.
Yes, I cannot reduce it. So I'm going to take the numerator times the denominator. 2 times 3, which is 6. What that means is I'm going to use 6 to rename my first fraction. And then I'm going to divide by the 2/3, right? So yes, 6 times 3 is 18. 4 times 6 is 24. Now if I divide, 18 divided by 2 is 9. 24 divided by 3 is 8. 9/8, or 1 1/8. How on earth did we get from this to multiplying by the reciprocal? Well, it's not as big of a leap as you might think. At some point, somebody looked at this problem and said, we're taking 3/4 times 6/6 and then divided by 2/3. And what they noticed is, kind of like with the cross multiplying and dividing, we're changing the order of our operations a little bit. What they noticed is here, if we played with the order of our operations a bit, if I divided first, 6 divided by 2 is 3, 6 divided by 3 is 2. What I always get is this fraction just upside down. So they named that the reciprocal. And then what's left is to just multiply. So multiplying by the reciprocal is nothing more than skipping a whole bunch of steps in this process up here. But it works every time, so that's how we're going to do it. I just wanted you to see where that process of multiplying by the reciprocal comes from. So if I have 5/8 divided by 2/3, what's that going to become?
5/8 times 3/2.
5/8 times 3/2. Remember, the division operates on the number that comes after it. So what do?
times 3,
5 times 3 is,
15,
and then
8 times
8 times 2,
is 16.
15,
So 15 sixteenths. Or we might have 7 twelfths divided by 3 fourths. What's that going to become?
9 4/3,
7 twelfths times 4 thirds. Now, this is multiplying now. So what can I do before I multiply here?
reduce,
I can reduce. I can cross cancel both the 12 and 4. Divide by
3,
4.
4,
So 4 divided by 4 is
1,
1. 12 divided by 4?
3,
3. Perfect. So 7 times 1?
7,
7,
7. And 3 times 3?
9,
9. So 7 ninths. What do you think? Well, by now, some of you have probably figured out the ABC key on your calculator. So all these operations I just showed you can be done right on your fraction calculator. So let's look at some that your calculator can't do. You knew it had to come. Actually, let's do this. 5 twelfths plus 3b over 4. Common denominator here is going to be pretty simple to find. Between 12 and 4, what's my common denominator? It's 12. Sometimes one of your denominators is the least common denominator because 4 goes into 12. So the 5 twelfths just stays 5 twelfths. Down here, what did I have to do to the 4 to turn it into a 12?
multiplied by 3,
Multiply by 3. So the 3b has to be multiplied by 3 to make
9b.
9b. Now here's the tricky part. I'm going to add, so I'm going to combine the counts. What is 5 plus 9b?
5 plus 9b,
Exactly. It's just 5 plus 9b. Over
12,
12.
12. We keep the same name of 12. That's not always quite so simple. Simple. We can run into 5, 6 plus 3 over 4x. What is my common denominator going to be? 12 would be the number, yes. 12x, very good. So remember, I have 6 and I have 4x. I could factor those. 6 is 2 times 3. 4x is 2 times 2 times x. The top one needs an extra 2 and an x. The bottom one just needs a 3. So that both multiply out to be 12x. So what did the 6 have to be multiplied by? 2 and x. So 5 times 2x is 10x. Good. What did the 4x have to be multiplied by?
3,
Just 3. How about 3 then? 3 times 3 is
9.
perfect. We get 9. So when we add those, we get 12x plus 9, or 10x plus 9 is 10x plus 9, all over 12x. Cannot reduce that any further. What if we have 5a over 8 plus b over 6a? I'm sorry, not plus. I meant to say minus. 5a over 8 minus b over 6a. Our first step is still to find the common denominator, least common denominator. 8 is just 2 times 2 times 2, correct? 6a, well, 6 is 2 times 3, and then a. What's the top number need? 3 and an a. Bottom number needs 2 more 2's, right? What's that multiply to be? 24a. Very good. Now, actually, if I look at this, it gives me a little bit of a recipe even as to what to do. 8 had to be multiplied by 3a to make 24a, right? So 5a times 3a is 5 times 15a squared. There we go. Perfect. 15a squared. Good. 6a had to be multiplied by, well, 2 times 2 is 4. So 6a has to be multiplied by 4 to make 24a. b times 4 is 4b. So now we subtract. What's 15a squared minus 4b?
15a squared minus 4b.
Perfect. 15a squared minus 4b. Over?
24a.
24a. Good. Well, that's not so bad, is it? Better than a sharp stick in the eye? Some of you thought way too long before answering that.
How sharp is that stick? How far are you going to push it in there?
That's the question about halfway through the summer. I always get, how far are you going to push it in? At the end of the summer, it's like, well, would you stop at the back of the skull? That's kind of morbid. So anyway, what if we have 3x squared over 8 times 12 over 35 x to the 4th. Well, there are a couple of different ways we could handle this. I'm going to first show you the simplest way to do it, but it kind of gets in some ugly numbers. And then I'm going to come back and I'll show you a way to do it that's a little bit easier, keeps the numbers a little smaller. Probably the simplest way to do it is to just multiply them out. 3x squared times 12 is
36x squared.
36x squared. Good. 8 times 35x to the 4th. That's 280
X to the 4th.
x to the 4th. This can be reduced. Just like we were doing last hour, 36 and 280 can both be divided by, well, let's start with 4. What is 36 divided by 4?
8.
9. And 280 divided by 4? 70. Can I reduce that any further? No. So 9 over 70 is the numerical part of our answer. What happens with the variable? Yep, so is it going to go top or bottom?
Goes on the bottom.
Goes on the bottom because 4 is bigger than 2. And it'll have a power of
2.
2. 4 minus 2 is 2. So 9 over 70x squared. The other way we could have done that problem rather than multiplying it out and reducing it down, I could have pulled out the numbers and worked with them first. Here I can cross cancel the 9 and the 12, or the 8 and the 12, both divide by 4, right? 8 divided by 4 is 2. 12 divided by 4 is 3. So 3 times 3 is 9. 2 times 35 is 70. So that gives us the 9 over 70. Then I could do x squared times nothing is x squared. Nothing times x to the 4th is x to the 4th. So that does reduce to the x squared on bottom. So this way saves you a little bit of calculation with the numbers, keeps the numbers a little smaller. This way probably has fewer mistakes. So let's take something like 9y to the 3rd times 20x, or over 20x, times 16x to the 4th over 21y to the 5th. Now, as always, I could multiply this whole thing out. 9 times 16 is 144. Then x to the 4th, y to the 3rd. Why did I put the x to the 4th first? Alphabetical order, right? X comes before y. 20 times 21 is 420. Then x, y to the 5th. And then I do have to still reduce this. 144 over 420. What can both of those? What's one thing that both of those can be divided by? Let's try 2. 4 would work, you're right. But 144 divided by 2 is 72. 420 divided by 2? 210. Now I can see a little bit better that both of them can be divided by maybe 6. 72 divided by 6 is 12. 210 divided by 6 is 35. Can I reduce them any further? No. 35 only divides by 5 and 7, and 12 can't divide by either one of those. So that gives us 12 over 35 is the numerical part of our answer. And our variables. X to the what? 3 on top, because the 4 is bigger than 1. And yep, because that's a 1, right? 4 minus 1 is 3. Yep, x to the 1. And then on bottom we have y2, good. 5 minus 3 is 2. The bigger one was on bottom. So 12x to the 3rd, y squared. I'm going to do 6. So 3x to the 5th over 10y squared times 25y over x to the 4th. I want to multiply on top. What do I get on top there? 75 x to the 5th y. On bottom, 60. Yeah, I do x to 4th y second. Yep. Then we do have to reduce 75 over 60. Both of those can divide by, just for the sake of time, because we're running short, I'm going to tell you it's 15. So it gives us 5 over 4. Can I change that to 1 1/4?
No,
Why not?
because exponents.
Because we have variables. Very good. When there's variables involved, we always leave it. We cannot change it into a mixed number because we don't know what numerical value those variables have. So we've got 5 over 4. What's going to happen with the x?
Subtract 4.
So,
On top,
So you just have x on top.
5x,
okay. So just x on top. What happens to the y? And the y on bottom. Perfect. 5 is bigger than 4. 5 minus 4 is 1, so it's x to the 1 or just x. This is y to the 1, so 2 is bigger than 1, so y is on bottom. 2 minus 1 is 1 or just y. And of course, division.
you can't cross multiply on those ones?
On these, you could cross cancel, yes. One of the things you could have taken this and separated out the numbers like this, and yeah, you could have divided out, make 1 and 2, both those divide by 3. Both of these divide by 2. Oops, that should be a 25 there, not a 24.
Divided by 5.
So both of those divide by 5, which would give you 2 and 5. So that gives you the 5 over 4. Yes, you could have done that.
That's what I did. So I just did it.
Yep. And if you're good, and you can actually do it right in here if you're good at it. Some people find it hard to keep straight of the variables if you do it right there, but if you're good at it, you can do it right in there. So let's see, 14 x to the fifth over 15 y squared divided by 10 x to the third over this is going to, why not? 21 y to the fourth. We'll go y to the fifth. All that we really have to do to this problem is remember that division becomes multiplying by a reciprocal. So the second fraction, we take the reciprocal. 21y to the fifth, 10x to the third. Now it is a problem we have already solved. We just have to multiply. And yes, you could cross cancel here if you wanted to. Be careful. Do not cross cancel the 14 and 21 up here because it's division. It's not multiplication yet. You can't cross cancel.
The 14 and the 10, and then the 15 and the 21, right?
Exactly. Yes.
Okay.
We're just going to go ahead and multiply them out and then reduce it later. So 14 times 21 is 294, right? X to the fifth, y to the fifth. 15 times 10 is 150. X to the third, y squared. And now we do have to reduce. The 294 over 150, both of those can divide by, well, not 10, not 5, but they can divide by 2. So what is that? 147 over 75. Are we done? Say no. They can both be divided by 3, right? Gives us 49 over 25. So then we've got x squared on top and y to the third on top. I know I flew through that last example, but we have exactly 1 minute left. There is a new quiz due tonight. at 11:59 p.m. There's new homework that is due tomorrow. Yes, at noon, so in class tomorrow. Now, I realized that my math lab was malfunctioning. They updated it over the weekend, and something went wrong. They usually update it late at night, usually like midnight till 4 in the morning, and I believe they did that Saturday night through Sunday morning, and something went wrong with their update, so they were working on it all day yesterday. So if there are any of you that are still working on the homework from last Thursday, feel free to keep working on it. The system is going to tell you it's going to take off half the points. Ignore it. If you get that homework done, and if you do the first attempt on the quiz and you're confused because you didn't get a chance to ask, I purposely didn't answer any questions on the homework today because a lot of you didn't get a chance to do it. But if there's still questions on the homework that didn't get answered by the first part of today, let me know, and I will extend the quiz for you guys so you guys can redo that quiz tomorrow. Remember, however, that coming up on Thursday is test 2 already. So I will be on the network till noon here. The computer labs will be open for you to use pretty much all day, I believe. I don't think anybody uses any of these labs. So if you want to work on stuff, feel free. Otherwise, we'll see you tomorrow. Have a great day.